Hello, I'm Dave Kassler, amateur radio call sign KE0OG, and I write the Ask Dave column in QST. This is a supplemental video that goes along with the column from December 2024. In that column, I talked about a radial plate and how you can make radials and utilize one of those radial plates. So I thought we'd talk about it a little bit more. This is the picture that was in the column showing all of the radials coming to that plate. It's a stainless steel plate, and you use stainless steel hardware with it. If you use aluminum hardware, which is real easy to get down at Home Depot, you'll eventually have a corrosion problem, so use stainless steel. Also make sure that you use an anti-seize compound, because stainless steel is famous for kind of locking in there, and instead of unscrewing nicely, it actually breaks as you try and unscrew it. So what I wanted to talk a little bit about was the radial plate, which is this plate from DX Engineering. You'll note that it has a raised part in the middle to which you can connect an SO239 or something like that, so that you will have the availability of the whole thing, and then it will also connect up to your antenna. Designed by DX Engineering to be used with ground-mounted vertical antennas. Of course, the bottom of the vertical antenna does not actually touch the ground. It's connected to some sort of an insulator, like a big, thick, tubular piece of plastic, so it'll stay upright. And often it's a good idea to go ahead and guy vertical antennas at about the 2/3 point up with some nylon guying or some kind of wire, which DX Engineering sells, like Mastrand, that is plastic, so it won't affect the performance of the antenna, but it will keep it from putting too much sideways pressure on the thing that insulates it from the ground. So let's return to the ground. We've got all these radials. Now, how many radials do you need? Well, the classic answer is the more the better. However, it seems to top out at about 360 radials 1 every degree. That is way beyond what's necessary in here. As you add more radials, you will add a little bit more antenna performance. It should be noted that going from, like, say, 4 radials to 25 can give you about 3 dB improvement in both the gain on transmission and on reception. So it is a nice thing to do. Now the question is, what do I use for wire, and how do I handle it? Well, first of all, we want to use insulated wire. This is readily available at Home Depot. Here shows a 500-foot roll. I chose gray because that is the hardest to see from a distance. But what I recommend, this is stranded wire. This happens to be 12-gauge wire. You can use 14-gauge wire if you want. Actually, you could do 16-gauge wire if you wanted. The current that goes up and down the vertical also flows out to the radials, but it's divided among them, so the current in any one radial is not that much. What we do is we lay these on the surface, okay? Now, with time, grass, bushes, things like that will grow up over these, so they won't be as much of a tripping hazard. But for the first year or two, they are a tripping hazard. Now, do they have to be perfectly straight? No, they can wiggle and bend and whatever. You'd like to keep each one in its own ground track. But the fact is that the radials pretend to be a large plate, large cylindrical plate that is carrying the RF current, and it goes out to the edges and back in, out to the edges and back in. Now, how long does a radial have to be? Well, when you're overground, it doesn't matter much. I've had very good luck with as short as 10-foot radials. My favorite length for them is 25. If you go with 25-foot radials, you will get 20 of them out of a roll of 500 feet of wire. That's less than $100. Although I will mention that the cost of copper is highly volatile, so it will go up and down with time. So I would choose 25-foot radials, 20 of them each. You spread them out. You can use what are called lawn staples to kind of hold them in place at the end if you want to. So let's do this. Let's show how we would treat the end of a radial. I mean, the first obvious thing is that, as we saw in the radial, there's lots of nuts and bolts. Just wrap this around it and tighten it. I don't recommend that. I recommend putting a connector on the end. Now, this is the kind of connector that we can put on here. And this will give you a solid, and I'll add perpetual contact. Now, these are 12 or 10 gauge American wire gauge ring terminals, and they are a 1/4 inch in diameter. These are the ones that are designed for the 1/4 inch studs. If you have a problem getting them over it, hold this down very well. Don't hold it with your hand, but in a vise or something. Take a 1/4 inch drill and just go through it a time or two to make sure it's the right length, okay? Now, the reason that we like to do stainless steel is because this is at the bottom of the vertical, and if anywhere on the vertical is going to be wet, it's going to be right there at the radial plate where these things are mounted. Now, the far ends of these radials are just left on the ground or held down with a round staple. And as you see here, you can get these from Home Depot also. They're just pieces of wire, as you can see, and you can push them easily into the ground if it's not rock. If it's rock, use a rock to hold down the radial, and you'll be fine. Now, a question has been brought up before. At the center of the bottom of the vertical, where all the radials come together, should that be insulated from ground? And the answer is no. In fact, you'll probably get slightly better performance if you drive a ground rod right at the base of the antenna and connect it to the radial plate. And that way, you've got the ground at the center. The radials work away from that. Now, what about the exposed ends of the wires? You could put a wire nut on it if you want, but if you'll just keep this out close to ground, you'll be fine. Now, why can you use different lengths of radials? Why don't you have to use a specific length, like a 1/4 wavelength? The answer is that the radials tend to capacitively couple with the ground. And so you are getting a little bit of a grounding effect. Now, let's show how we will put one of these together just to see it. I propose that we both crimp it, which gives us a good short-term connection, but in the long term, you can get a little bit of corrosion between the terminal here and the wire. Actually, we're going to trim a little off the end here and send it through. If you want, you can remove the little plastic part. It doesn't serve any purpose here. Everything at the center is grounded. Okay, so what we're going to do is take this plastic end off just to make things a little easier to see. Hold on very tightly to that. And then just reach in here on the plastic part and pull. Okay, and then you have the actual connector. And again, this will be at ground potential, so the insulation you can either leave on or leave out. Now, we only need a little bit of this actually connected. I'm going to make it a little bit longer so that the wires come out onto this flat part, because not only am I going to crimp, but I also am going to solder this thing on here. The solder will make a permanent connection, but the strength will be in the crimp joint. Okay, you see here that it's a piece of metal that's been around here and been around here. This is the seam. We want to crimp so that the seam is pushing into the wire. If we crimp on the other side of it, then what we're actually going to do is just simply pull that seam apart. So, okay. There we go. Now, we're going to use the simpler crimp tool. It does not crimp as wide a spot on this, but it'll do. Now, the difference is, the first thing we need to do is push this through here, like that, okay? And we want it to come up only part way where we can solder it, but at the same time, you can get the nut on this without the nut encountering that. So I'm going to hold it right there and put it in this spot. Well, that's crimped. It's not coming out of there. Okay, I'm going to put the screwdriver under here and kind of bend these up a little bit. So I don't want them in the way of the nut. So we will use wire cutters to kind of trim these a little bit. So what we're going to do now is put this in here. Now, I'm having a little trouble doing this because I haven't done it in a long time. You will have the same amount of trouble doing the first of yours, but then it will quickly get quicker and you'll get to a nice routine. So what I'm going to do is, with a nice hot soldering iron and a little bit of rosin core flux, we're going to solder this. Okay, so the nut will go through that, and that wire is kind of out of the way. It is also soldered in position, so there's no going on here that would cause that there to be corrosion between the crimp and the wire, which can happen. So this then connects to the radial plate, and then this extends out for, say, 20-25 feet as the radial itself. Okay, so what we have seen in this particular exhibition, besides how shaky my fingers are, is that to make the radials really stay on forever, to where there is no maintenance, you both crimp and solder it to a connector that's the right size that the bolt can go through, and put the nut up on the other side. Again, I will suggest to you that when you buy the radial plate, it will come with enough hardware for about half the holes, or a third of the holes. You can buy more hardware from DX Engineering, and that way you know that you're getting stainless steel parts. The reason for the goop to put on them, very thin layer, is so that when you want to undo them, they'll come apart. If you don't, it is possible that sometimes when you try to undo a bolt on stainless steel, it will just shear right off. The time will come when you want to take the nut off, and you may find that the bolt or the nut will simply shear off. And that's because it takes quite a bit of pressure to undo them. Okay, so there you have it. We've got just a little bit of an extra for that edition to talk about radials, a little bit about where you can get the wire, how you can connect them so that they have very little maintenance in the future. All of the bolt and nut sets in there come with star washers, which will grip into this connection very, very well. Okay? Helps you make something that just won't come apart for the long term. So there you have it. I hope you enjoyed that. I also have my own channel at youtube.com/Dave Kassler, all one word. And I look forward to seeing you for next month's supplemental QST issue 73.